Okay, here we go with hyperbolas part two. I'm going to start out with this example that we've got here, that we have an equation for hyperbola, and I just simply want to graph this. So I'm going to start with something that's a little bit more challenging than what some of the more basic ones, what your assignment or our in-class activities are going to start with. But jumping right in, first thing that I'm going to notice is I like to think of my hyperbolas. I try to make them as similar as I can to an ellipse, to a circle, all of those things, so that we've got that commonality in those common skills and tools that we can use. So what I look at here is, even though a hyperbola doesn't truly have a center, I'm going to say that I have a center because everything is based around this. Everything's going to be symmetrical around this, above, below, rotational symmetry. I'm going to say that I have a center here. I'm going to use my h and my k. Got a center of 3 comma 2. Now, a little bit different situation here than with ellipses. An ellipse, its major axis is determined by whichever one of these numbers underneath of our x and y, the 4 or the 9, whichever one of those is bigger. Not the case with a hyperbola. Instead, whichever one is positive becomes our major axis. So I'm going to go ahead here and I'm going to say our major axis is, well, the square root of 4, so it's going to be 2. It's going to be 2 units long. Our minor axis, oh, and I'm sorry, I should put a note here that it's horizontal. Our minor axis, in this case, is going to be 3 units long, and it's going to be vertical because it's underneath of our y's. Now, major, minor, I'm going to name them that same way, but truly we only have one axis when we talk about a hyperbola, and I'll show you what I mean once we actually go to graph this. So let's see what happens here. Going back, sorry, forgot. So my center point is 3 comma 2. 3, 2. Put a little x there. Not actually part of my graph, but it's going to help me out. Major axis is horizontal, so I'm going to go 2 units to the right. Now that is actually going to be a point on our graph. 2 units to the left. Okay, my other two are not actually going to be points on my graph, so I'm going to go 3 units up and 3 units down. And what I do with those 4 points now is I'm going to take and I'm going to draw a box. Now I'm going to draw a horizontal line through my top point, horizontal line through my bottom point, vertical lines through my other 2 points. And if I were doing this with a pencil, I would definitely make sure that these were nice and light so they weren't distracting, because again, these are not part of my graph. They're helping me get my graph. Okay, so what this does now is it actually makes it very easy for me to graph my 2 asymptotes. Yes, hyperbolas have asymptotes, those lines that it gets closer and closer to, but are never going to touch or cross. And those asymptotes go across my diagonals of this box that I just created. There and there. Perfect. Okay, so now I've got these 2 asymptotes. I know that my hyperbola is horizontal because I had a horizontal major axis. This point has to be a vertex on one of those sections of my hyperbola. So I'm just going to make it go nice and close to that asymptote. I'm not worried about anything real specific here. I've got all my pieces, all my components that I need. There's the other half of that side. My left side is going to reflect that. And there is a rough sketch of the graph of my hyperbola. Now, going back here, we may be asked sometimes to find the asymptotes. Now, my favorite, I'm just going to keep it simple. My favorite is just to go ahead and use the graph to find those 2. So let's see, I look at this one, and it looks like I go up 1, 2, 3, 4, 5, 6. Hey, that's 2 times whatever in this case, my B value was. So my rise is 6 over my run is 1, 2, 3, 4 over 4, which simplifies to 3 over 2. It's not a coincidence that my slope for my asymptotes is going to be B over A and the opposite of B over A. It's always true. The slope of my asymptotes is always going to be plus and minus b over a. Okay, so let's see. Now I've got one of those is going to be y equals 3 halves. I'm going to use point slope. X minus, oh, I know that they go through my center point. My center point of my hyperbola was 3 comma 2. 3 plus 2. And my other asymptote, let's simplify that first, I suppose. Y equals 3 halves x minus 9 halves plus, I'm going to write that as 4 halves. Y equals 3 halves x minus 5 halves. Okay, my second asymptote, y equals negative 3 halves x minus 3 plus 2, still goes through that center point. Y equals negative 3 halves x plus 9 halves plus 4 halves, or y equals negative 3 halves x plus 13 halves. So those are the two asymptotes of my graph.